This is section 2.3, secant lines, and we're also going to look at maxes and mins on the calculator. So make sure you have your calculator out, ready to go. And as always, I'm available during the video on the chat during class, and then it will be posted on Classroom and YouTube for you guys to view and pause as you'd like. Okay, a secant line is a line, as you know, that goes through a graph in 2 points. So I'm going to randomly draw a secant line. Okay, and 2 points on the secant line will be, here's x1, y1, and x2, y2. Oops, that's supposed to be a 2. Okay. We're going to talk about average rate of change. And if I want to talk about the rate of change, you should also know that's the same thing as the slope. Average rate of change is the equivalent to the slope. Okay, so when we talk about rate of change, this is going to become important when we look at velocity and acceleration. And I know I've mentioned that before numerous times, but it really is the truth. I can find the slope between these 2 points. And we know the formula for slope is y2 minus y1 over x2 minus x1. Okay, so we're not going to really use x and y anymore. We're going to be a little bit more sophisticated in our lettering. So I could say that this would be x and the f of x. And this would be x2 and the f of x2. Y, f of x, same thing. So instead of using x and y, generally we're going to use a and b. So I'm going to say that this is a, and the f of a. It's no different than x1, y1, x2, y2. It's just using different variables. And this is b, f of b. And why do we use a and b? I have no idea, because whoever decided that rate of change was important decided to use a and b. When you invent some really cool thing, you can use whatever letters you want. So average rate of change is going to be the f of b minus the f of a all over b minus a. Okay, so let's do an example. You're going to have some function. Let's say our function is the f of x is equal to negative 2x squared plus x. So this is a curve. It's actually an upside down parabola. And how can a parabola have slope? Well, it doesn't, but a parabola can have a slope between 2 points. So you have some curve. So this, in this case, this is an upside down parabola. On this parabola, there are numerous secant lines. So I'm going to ask you to find the rate of change, the slope of a secant line from between two specific x values. So we're going to say from 0 to 3. And I just made that up. I'm just using 0 and 3. Okay, well, my a is 0, but I can find the f of a, can't I? The f of 0, I believe, is 0. So there's an ordered pair, 0, 0. And I could say, all right, if x is 3, so I can find the f of 3. And when I plug in the f of 3, I believe that is negative 15. If you catch a mistake, just let me know. Send me an email. All right, so I have another point, 3, negative 15. Now I can find the slope of this secant line, also known as the average rate of change. They are synonyms. So the slope is going to be negative 15 minus 0 over 3 minus 0, which I believe is negative 5. Okay, that's the slope. I could ask you to write the equation of the secant line. Equation, I just abbreviated it. I can ask you to write the equation of the secant line. Well, you know the slope. You could use either point. I tend to use point slope form. I think point slope form is much faster. So in case you have forgotten, point slope form, y minus y1 equals m quantity x minus x1. That's point slope form. There's standard form, ax plus by equals c. There is slope intercept form, y equals mx plus b. Point slope form is by far the easiest. Plug in, move on. So y minus, I'm definitely going to use the 0.00. Y minus 0 equals m times x minus 0. Y equals negative 5x. So negative 5 is the slope. Negative 5x is the line. Okay. You need your calculator for the next part. We're going to do maxes and mins on the calculator. All right, and I will write the problem down, but just so you know, this is page 79, number 62. And the equation is y equals 0.4 x cubed plus 0.6x squared plus 3x minus 2. Again, this is page 79, number 62. Okay, so let's just do a quick review. I believe, is this supposed to be negative? Yeah, this is supposed to be negative. Okay, it's a cubic and A is negative. So the end behavior is going to be up, down. Doesn't hurt to review that. I'm going to go ahead and plug that into my calculator. Negative 0.4. I'm going to hold the calculator up a little bit so you can see it better. Negative 0.4 x cubed plus 0.6 x squared. Oh, no, no, no. Negative 0.4 x cubed. There we go. Plus 0.6 x squared plus 3x minus 2. Okay, and I'm going to do a zoom 6. I always do a zoom 6. Takes me right back to where I was. Takes me back to the standard window. The standard window, x goes from negative 10 to 10, y goes from negative 10 to 10. Okay, so the problem asks you to specifically look at the interval from negative 4 to 5. So they ask you to look at the interval from negative 4 to 5. Okay, keep in mind that this is an interval. This is not a point on the graph. Okay, so I'm going to adjust my window. All right, I'm trying to hold the calculator in a way where the glare isn't so bad. So I'm going to go to window. And if they want me to go from negative 4 to 5, I'm going to make my window a little bit bigger. And I'm going to go from negative 5 to 6. And I'm going to graph it. And I should still have that nice smooth curve. Okay, so you can see on the calculator that I have a min and I have a max. I have a local min, because the minimum is like way down here, it's negative infinity, and this is a local max because it's going on up forever. Okay, so what I'm going to do is just draw a really, really, really basic sketch of this graph. Like super basic sketch of this graph. And it looks something like this. Great. Super basic. So I have a minimum here somewhere. And I have a maximum up here somewhere. And I'm going to start by finding those 2 points. Okay, I'm going to start by finding those 2 points. So on the calculator, secant trace. Second, trace. I'm going to find the minimum first. So either arrow down or push number 3. And you'll notice it says left bound. So I'm going to go to the left of the point that I'm looking for. And I'm just holding down the left arrow key, going to the left, and I'm going to push enter. You'll notice at the very top, I have an arrow. So it's telling me that's my left bound. And I'm going to arrow to the right. See at the top, the arrows are pointing to each other. So you are telling the calculator, please find the minimum between these two arrows. Guess, just going to get close to it, push enter. And I believe the directions ask you to round to the nearest hundredth. So this point is approximately negative 1.16, negative 4.05. Okay. Now I'm going to do the same thing with one slight keystroke difference to find the max. Second, trace. You'll notice that above trace it says calc. So I want the calculator to calculate something for me. And I'm going to do maximum instead. So that's number 4. And then I'm going to do my left bound, right bound dealio. So I'm going to just hold my arrow key to get somewhere to the left of the max point. How far left? It doesn't matter. I mean, I wouldn't be like super far away, but it doesn't really matter how close you get. As long as your left bound is on the left of the max and your right bound is on the right of the max. And you'll see up here, I have my arrows. So the calculator is going to find the maximum point between those arrows. And then for guess, I'm going to just put my cursor, close to it. And then it says that the maximum is at 2.16 and 3.25. Okay. I do not need my calculator anymore to answer the remaining questions. So I'm just going to put this down here. You do second, trace, choose max, min, whatever it is you want, and then set bounds. So the next question is, where is it increasing and decreasing? Okay, so if you'll remember from the previous lesson, when you're talking about increasing and decreasing, you're talking about intervals of x. What's happening to y between specific x values? So if I'm coming from the left-hand side, y is decreasing until I get to this x value, which is negative 1.16. When I'm talking about increasing and decreasing, this value is not going to be, the y values are not going to be part of my answer. So this is going to be decreasing from somewhere over here to the left to negative 1.16. Well, where's that somewhere over here to the left? That would be negative infinity. Infinity is always a parenthesis, always in a parenthesis. How do you include the biggest thing there is? You can't. Negative 1.16. This is a turning point. So it's going to be a parenthesis. And while we're at it, this is going to be a turning point. Okay. So it's going to be increasing. So remember, you're either increasing or decreasing, or you could be constant, but this curve is not constant anywhere. So starting at negative 1.16, and I'm going to the right, going increasing until I get to the x value of 2.16. And then from my max, my high point, I'm decreasing again. Y values are going down. So I'm going to do in union. That weird funky U means in union with 2.16 to infinity. And that is secant lines and increasing and decreasing on the calculator.